Math Map Book Club, where ordinary parents encourage one another to develop an extraordinary appreciation of math. We love what we know and struggle over the unfamiliar. Through weekly conversation and exploration among friends, we can begin to enjoy ideas that seem difficult. Join our book club as we discover how math helps us to know God and to make Him known.
Welcome, everybody, to the Math Map. We are on September the 24th.
Uh-oh, we lost your sound.
Share my screen at the same time. There we go. Am I back now?
Yes.
All right, perfect. Okay, there we go. So hopefully everybody now sees the slides for lesson 9, straight lines, which means that we are officially into the second dimension. So everybody pat yourselves on the back that you have made it through 1D. We have talked every year about how 1D is the hardest dimension to get through, especially your first year in the Math Map. And part of that is you're just learning about classical math education. What does this look like? It feels so radically different from what you've done with other curricula. You're figuring out the flow of the lessons, the idea that we're doing a lot more than arithmetic, even though we call it the dimension of arithmetic. And so we think we know what we're getting into in lessons 3 through 8. But then we discover that there's so much more in there than just addition, subtraction, multiplication, and division. So if you've made it this far and you're maybe like panting a little hard because this has been some work, I want to encourage you that I think moving forward, most people start to get a sense of how the Math Map works, how to engage their students classically, but we also start to see a little bit more unity and singleness in the lessons, not quite so much in every lesson. So I think that you will find that that works well. So I am going to figure out why my mouse isn't working, and let's look at our next slide. So we are here looking at our flashcards as we do every week to talk about what those flashcard strategies might be. And I just realized that this went black. Thanks for bearing with me that this has gone gray for some reason. I'm not sure why. It's supposed to be black because it's current, but thanks to Jana for filling me in on how they work through their flashcards, how they systematize their practice and celebrate the accumulation of knowledge over time. So they start, and this is her box. You can see Jana's name on the box. This is her box that they use, which I think just makes it feel so approachable because there's one box. And at the front, they've got their daily flashcards. So these are the flashcards that we are either just reading to learn what they say, or we're practicing in order to load it into our memoria. But we haven't yet started to gain any kind of mastery. So every day we're pulling those flashcards out and we're practicing those flashcards. As the student starts to gain some confidence in those flashcards and feels as though they know them well, they graduate. And this is the opportunity for celebration because we don't just put them aside and say, that's it, we're done with those. We now move them to the odd and even. So if it's an odd day, so for example, today being the 24th would be an even day, we would look at the even flashcards. And so as we go through, they get put in that odd or even day, and then they're practiced every other day. So we're still celebrating the fact that we know these flashcards, right? That we're not just putting them aside, but we're giving our student the opportunity to really feel as though they're doing well. And then over time, as they become even more solidified, they can be swapped into a day of the week and then eventually a day of the month. And so it's a way to continually practice and celebrate what we know while not just putting them aside, right? This gives us a system. So I just thought this was really helpful. And thank you to Jana for sharing her system with us, and even more for sharing a picture. Does anybody have anything they'd like to say about this strategy for going through the flashcards?
Can you hear me, Kiersey?
Yes.
Yeah, I was just gonna say, we don't put all of the flashcards in there. Obviously, there are some like the some of the fractions or the multiplication or whatever. We don't necessarily, we tend to put ones we struggle with a little bit more, or the notation cards that really take a little extra work. Just so that this is not, I mean, because otherwise you could fill it up immediately. But you know, like when you're trying to memorize what an algebraic number is, it's really handy to look at that day after day for a few days in a row, so that it's getting, you know, like we do in foundations, it's getting into your short-term memory, and then, you know, you revisit it to keep it in your memory. So anyway, I just wanted to point that out. Like, this obviously doesn't hold all my decks, but just individual ones. So that makes sense.
Yeah, no, absolutely. And I love the fact that it means that it's customizable for every family, because as you can see, not everything's in the daily section. So you can, as those daily ones are graduating through, you can add more in to that daily section. So no, I think it's a really great system and really encouraging reminder, right, that we don't have to be doing everything every day.
It's another, I like this system just because I was thinking, I don't know if it was this week, somebody was mentioning that you could use the flashcards for assessment. You know, if not everybody likes to use careful calculations as assessment. And so I think this system lends itself to using the flashcards for assessment, you know, because you can see how many they you know, got right on a particular day, or, you know, whatever the case, wherever you're moving it. And I think it's a good reminder that these, like the grammar and the addition and multiplication, I mean, that's a great way to assess. It doesn't necessarily have to be pencil and paper and I have to give a quiz, right? It can be an oral thing where you're just asking them questions that they've been drilling every day.
That's a really great reminder of ongoing assessment, right? That we sometimes think, oh, it's Blue Book, it's time to assess. But we all assess, whether or not we stop and think about what we're doing as assessment. We're all assessing our children every day, right? We're going, well, you know, obviously we need to work on putting dishes in the dishwasher, right? I'm assessing how well my child is loading the dishwasher, right? Because I see that it's not happening. And so we need to go back and retrain, right, on how we load things in the dishwasher. Or whatever it is, we're constantly assessing. And sometimes maybe we just need to be reminded that we're doing that so that we can acknowledge that we are doing these things in our homeschools, because sometimes it's tempting to think, oh, I haven't done this because it wasn't official, right? It wasn't pen and paper. And so just that reminder that, hey, if you're working through the flashcards and you're using a system to say which ones do we know and not know, that's a form of assessment. And ongoing assessment is really helpful. So looking at our covers, and if you remember last week, I said that I was going to try to keep the questions so that they lined up, going from our core habits to our common topics and now our canons of rhetoric. And so when we think, our first one was the topic. So this week it's straight lines. And a good question to ask here would be, what do you remember about the topic? That's a good memoria question. Now, we can use those memoria questions with our younger students, but a lot of the times we tend to think of those canons of rhetoric as being something that we're maybe using with our older or more experienced students. So I probably would not ask a student in their first or second year what they remember, but certainly by their third year, asking them, what do you remember about this topic? Right? What is it? Or you could break it down if you wanted to ask your first or second year student something. You could say, what do you remember about lines? Right? So maybe we're not going to add the straight on and think about the topic of the booklet, but we've talked about lines before. What do you remember about lines? So asking them what they remember. As we look at those number sets, the number sets that we've talked about that are over on the left-hand side. So here are number sets. We've got 3 different number sets represented here. Right. You could ask your students, what questions do you ask to invent what you know about the number sets? And I know that that's really awkward, but I wanted to get that idea of inventing or invention in there and remind us that invention doesn't necessarily mean that we're creating something new, right? But that we are drawing, it's how do we draw from our memoria and pull that out, right? So that we see what we know, that idea of invention. Because usually when we're inventing, right, if you think about an inventor, they might seem like they're doing something new, but it's usually building off of what they've done, right? So they've had some experience that has led them to go, this doesn't work, or this could work better, right? And so then they go, oh, if this worked, right? And so they're pulling from their experience in order to see what new thing they want to create. And so when we think of these questions, we're saying, how do we pull from our experience in order to create, right, this next step? We actually had a Uber driver who was an inventor, and it was really interesting because his big invention that he was working on was a scoop that had a different shape. It wasn't a round shape. It was shaped to match the bottom of a can, right? So, you know, like when cans are like either square or sometimes they're rounded. And so you get those bits that you can't get with a round scoop. And so he made the scoop match the bottom of the container. Right? It seems so simple, right? That seems so simple. But what did he say? He goes, well, from my experience, I was frustrated with what got left behind, what got wasted. And so how do I fix that? And so when we talk about invention, we're saying, what things can we pull out? What experiences can we remember? And so asking our students what questions are going to help us with that is pulling at that idea of the common topics as the skills of invention. So for your older students, especially who have that experience with those common topics, we want them to start pulling those common topics out when we say, okay, this is an invention process, right? Pulling from your memoria, this is an invention process. So what questions could you ask? So it's sort of a roundabout way of getting there, but that's where I was going with that question. When we look at the dimension and the symbols, so up in this top left corner here, where we've got our symbols for each of the dimensions, we can ask our students, what do those symbols tell you about the arrangement of the dimension? And you can also connect that to that blue bar that are on the I-squared page, right? Because last week we talked about why there were more symbols there than there were on the cover. So in 1D, our students might recognize, well, if arrangement, right, it's the points have been arranged in one line. But now in 2D, we've got points that are arranged on a plane, right? And we see that these 2 axes are telling us that they're arranged with a horizontal and a vertical component. So there's a way that we can bring this conversation of arrangement in as we talk about the dimensional symbols. We can always consider the elocution or style of the topic and ask your students, is it descriptive enough for the lesson? So if this lesson is called straight lines, is that descriptive enough? Does that tell you what this lesson is about? Or do you wish that they had included some other words? So just letting your students debate whether or not these are appropriate titles may be a good way to draw them into that conversation of elocution and style. And then thinking about the art, we could ask them, how would the delivery of the art change your perception? So we see it here, framed by the color. We could ask them, how else do we sometimes encounter art? Some of the art that we see may have been in a museum with an ornate frame. How would that change your perception of it? We're going to encounter some weeks where it's a photograph. So maybe you would have seen it just printed out as a photograph or on somebody's phone originally. How would that change your perception of the art? There's a piece of art that was a poster, right? So it wouldn't have been framed, it may have been hanging on the wall, right? How would that change your perception of it? So asking our students to think about how the art was delivered, right? And how does that change your perception, right? When we look at these works by Audubon, which are amazing, beautiful works, right? We notice that he's got these sketches up here, right? So was this originally in his notebook, right? Was this originally something that he created to communicate his discoveries? And so if you had seen this in somebody's notebook, would that have changed how you perceived it compared to seeing it right up on a wall with a frame? So I think that's a really fun conversation, especially with older students, to think about how that delivery might change your perception of the art. Does anybody have anything they'd like to share about our exordium as we talk about the cover?
I don't think I've ever thought about the delivery. And this is a good one to think about since he does have the stuff at the top. I'm cleaning out a room and I'm finding old notebooks where my kids drew, you know, little pages. And of course, that's different than something you hang on the wall. But now I kind of want to hang them on the wall. I don't know how I would do that, but it just makes you think about the delivery because I don't know that I've ever thought about it in that way. Like if this was like maybe they took off the scratch part and they just had the pretty frame, would we think about it differently? Or would we even attend enough to know that there's the scratch, the notebook part at the top?
I confess that I thought my child had doodled on the page. I was a little bit annoyed. I was like, it's brand new. How did you doodle on this page? But clearly that was not the case.
That's really funny. All right. So day one, we practicing our flashcards every day. Day one, we're having this rich conversation about the cover. And I just want to encourage you that it's okay to have these conversations every year because every time we look at these covers, we can see something new, right? It's going to hit us a little bit differently, and we're going to come at it with a different set of eyes because we're going to have experienced different things in the intervening year. We can ask different questions each year to draw different things out from our students. So I just want to really encourage you that there's a richness to looking at this year after year and seeing the growth that you have in your conversation. And similarly, just because a challenge student has talked about it in community, you can still talk about it at home. And it's a great opportunity to get a little bit of a glimpse into the conversation that they had in community. Maybe they heard something in community from another student that your family hadn't thought about before. And so I just think it's really important to take this time and have this conversation. Some of us were blessed to listen to a webinar last week with Dr. Francis Sue, and he is one of my favorite mathematicians, modern mathematicians. He's obviously brilliant. He's got his PhD from Harvard in mathematics. He's a brilliant math mind, but he is also a Christian and also sees math as fundamentally essential to being human. And one of the things that he talked about on his webinar was the importance of inviting our students in, not through arithmetic and computation, but through this idea of contemplating beauty, right? Or thinking deeply about things. And so I think those of us that were able to hear him last week were really encouraged that one of the things that he said he felt was most important for raising up a generation that love math was doing what we're doing here by including our students in these conversations. I'm not certain, but I'm thinking that on our Facebook page, we may be able to tag you to a recording of that. So if you're interested, watch our Facebook page, because I think once that becomes available, Babs may be able to put it there. Also on day one, we take a look at our map, right? And we're practicing. Not only are we taking advantage of the opportunity to know where we are, but we are also practicing how to read a two-dimensional array. So we're going to pick whichever domain that we're in, and we're going to look along our straight lines, and where they intersect, we can put a check mark. And we've talked about how there's so many ways to use these math map pages as a parent and as a student, that if you want to have one that you refer to every week to check it off so your students could see the progress, you could use other ones to keep track of what went well or what didn't go well, what you want to revisit later on. So it becomes a really great tool for a lot of different record keeping purposes as you work through the math map. And then we get to our lesson pages. So I just want to remind us all that we don't start with our lesson pages, that just like a piece of art is enhanced by having a frame, right? The beautiful frames are as much part of the work of art in a museum as the art that they contain. The frames are there to enhance the experience. And so taking time to look at those frames, those are the eye pages, the cover, the activities, that those are there to enhance the experience. So taking time to work our way into the lesson pages each day is important. So we've talked a lot about different strategies that we can use, and they've probably tended more to how do we tailor this to somebody who is not quite ready for the domain that they're in, or has some gaps that they want to fill, or isn't working as quickly as one might think if they were going to get all 16 pages done. So we've talked about ways that we can tailor the curriculum to make the lessons accessible to students of varying abilities, varying working paces, varying experiences. But I also want to take a minute and take a look at some strategies for those students who are zooming through this and want more, right? We know that there are students maybe in their second or third year, some students in their first year who pick up the pattern and they're zooming through their lessons and they're like, okay, I want more. So instead of saying, let's just go to the next booklet, right? Or let's change domains and go to a harder domain, I want to encourage us to stay in the appropriate domain, but encourage our students to think more deeply. And so the first way that we can do that is by asking our students to demonstrate good questions or explain the patterns that they're seeing. So it's one thing to notice the pattern, 1, 1/2, 1/3, 1/4, 1/5, right? I can recognize that, and you can all sit there and I can say, what comes next? And you would all say 1/6 because you recognize the pattern. But if I said to you, why is that the pattern? Or what mathematical words could you use to describe the pattern? Or do you know that that pattern has a name? Is that a common pattern? That we can take that from where we might have a student who's really good at picking up the pattern, but when we say, okay, now I want you to go back and I want you to explain what the pattern is, and they go, well, I just know it, right? We see that we're at one level. But if we can help that student to go, well, my denominator is changing and my numerator isn't changing. Well, that's interesting, right? Because now we're using some mathematical language to compare our numerator and our denominator. And then we might say, okay, is there a relationship between, right, the number and their order? So 1 is first. That makes sense. Well, how did 1/2 become second? And they might say, I don't know. But if they think about it for a little bit, they might go, well, second and 1/2 both have a 2. Well, third and 1/3 have a 3, and fourth and 1/4 have a 4. And then they might notice, oh, wait, this is the reciprocals. Wait, there's another math word, right? I could use the reciprocals. So now I might say this is the sequence of reciprocals, right? And so we've gone from they can see the pattern, which is great, but we can encourage them now to go back and say, well, what is the pattern? Explain to me the rule. What math words could help you to explain that pattern back to me? Or you could say, what are some questions that you could ask, right? So I want you to tell me, how did you figure out the pattern? What was the question you asked, right? And so now we're requiring them to not just go, well, I got it, but to stop and think, why did they get it? Were they asking themselves a question? Right? What question might they have been thinking through to get there? So that's one of the ways that we could move our students who are moving through this more quickly and pull them back and say, okay, you want to go deeper? Here's how you go deeper, right? Not by going ahead, not by going to a different domain, but let's use what's here in front of us and really get everything that we can out of that. Any questions on that strategy for our students that are surging and looking to go ahead?
Would it be too early to ask the student to explain the problem? Like maybe they're, I don't know, in 7th grade and their sibling is in 4th grade. Could they explain it to their younger sibling, or is that too fast or too much?
I don't think so. I think that's a really great strategy, right? For an older student who thinks that they've got this, or even a student who maybe doesn't, but sometimes talking it out loud. So I saw today, I don't know how true this is, right? This is an internet thing. So I hold on to very little confidence that this is true, but it claimed it was called the rubber duck method. And it was this claim that coders who are trying to find errors in their coding will talk out loud to a rubber duck in order, because once they say it out loud, they find the errors.
My son
And
does that. It works.
there we go. It has been verified. Thank you. So now we see that it's true, at least for one person. But this idea, right, of talking through things helps us to see maybe a missing step. So I think that's a great idea, Babs, for any student. If you have multiple students at home, encouraging one student to explain it to another. And it could even be a younger student explaining it to the older student, right? It doesn't have to be, I know it and you don't, but hey, I want you to explain things to each other, because talking this through is going to help you to see things that maybe you had missed. So again, we're always coming back to, there's so much in the curriculum. There's so much on these lesson pages that we can rest in, right? There's so much that we can rest in these lesson pages and not feel like we have to go out and do more somewhere, but we can come back and look at these lesson pages and say, okay, there's always going to be more here if I want to find it. And so that's what we're going to do in the next couple of weeks, is just talk about how we can find the more when we need to. So that brings us to our lesson page 1. Does anybody have any questions about any of the math concepts on this page? So I just want to point out that there are two big ideas this week. One is that we're in 2 dimensions, and so there's going to be a lot of examining the pattern as we're moving into 2 dimensions. Things where there was a 1 of something in 1D, there's going to be a 2 of something in 2D. And then we're also looking at the idea that in 1D, there's one line, right? So I have 2 points and there's one line. That's all there is. But once we see that in the context of the plane, we're going to have an infinite number of lines. And so we're going to talk about how we can differentiate between different lines in the coordinate plane. And that brings us to day 2. So day 2, we're still going to drill our flashcards, and then our frame page for day 2 is to practice our common topics on the invention page. And so this week, we are on circumstance and some questions that you could use to discuss the circumstance of the invention page, or ask them, what are the places on the page? Help them to see that the page itself, right? Circumstance is what's happening in different places at the same time. So the same time as we're all here on the same page, but what are happening in different places on the page? And to help them answer that question, you could say, well, what are some borders or boundaries that would help you know where the places are? So they might notice, well, right, we've got these heavier bars here that seem to divide up our places. This looks like it goes together, but then we see that we could look, and I'm going to kind of do a dashed line sort of thing here, right? I could look at these as different places, right? I could look at a point or a line or a plane as different places. Or I might say, okay, what's going on with these things in 2D? Right? I could look in columns. Or I could look, I just want to look right here at this one place, right? And so we can think about how these different lines are going to act as borders or boundaries to know where the places are on the page. When we do that, we could ask our students which ones seem to go together, which ones might be separate ideas. So, like I just said, right, we see that this section here looks like it goes together, right? It's a table. And so while we might have individual places, it feels like it fits within a whole. Our other places may feel more separate, right? They may, but we might still see where talking about 2D, the second dimension, right, fits in with what we're talking about below, where we're talking about 2D. So we may still see a connection, but it may feel a little bit more separate. So asking our students, not necessarily about the math, right, but just giving them the opportunity to explore circumstance as, right, different places in the same time, that we can do that using this page. And then we can always ask our students, right, look at our dimension bar. Notice that this week we're going through 2D, right? Last week we stopped at 1D. This week we're going to 2D. So what does that tell us about the lesson that we're in? Right? We're now in 2D. And then our page 2. Does anybody have any questions about the math that might be here on page 2?
I have a question about, and I don't, oh yes, it's in monomials. It's in monomials as well. Vertical lines have the form x equals c, and then it just gives us these different x equals something, and then it shows us a vertical line. Can you help me know what to do with that? Am I supposed to circle one of those as an option, or how does that work?
Well, here, so notice that she's asking you to write the slopes and the y-intercept. And while there's a space to write that for our oblique lines and our horizontal lines, notice that the vertical lines here, she's already filled that in. So that's just an opportunity to really say to your student, okay, so notice she's given us this information. What do you think it means that it has an infinite slope? And why do you think it says not applicable for the y-intercept? Right? So that's just that I would just say is like an opportunity to discuss. She's already given you that information. So it's just an opportunity to discuss that or add that to your memoria.
Okay, so there is nothing to write for
There's
that.
nothing to write on that one. That's correct.
Okay, that's simple.
Good question. Yeah, a lot of times, so as you're looking at these lessons, hopefully you notice that there's this mapping, right, from integers to fractions to monomials, and we see that this mapping is going to carry all the way through. And oftentimes Lee will include information that I don't want to say that she thinks is too hard for a particular domain, but it might be the first time she's introducing it, or it might be something that she doesn't think is really obvious according to the pattern, or it's something a little different. And so she'll give students that information. And then the next year you might see now it's a blank to fill in, right? So that you get this mapping from year to year where it's more gradual. We're seeing some big jumps here. If you were to lay out all of the domains, you would see this more gradual mapping. And then you might see that if you looked at binomials, those might be blanks for you to fill in. But for monomials, she's gone ahead and given them the answers.
And it's the same in complex, because I don't have the week 9 for monomials in front of me, but I have the complex in front of me, which is what I'm working through. And it's the same. It's written out. And so there's no blanks, no nothing. And then in monomials, it looks like it's the same. So I was curious, is there any kind of notation or anything that's been added for us for when there is a sample or an example given versus we just have to figure that out on our own?
Yeah,
Or look at
usually if it's written in black, right, that's usually she'll try to usually make it right, the first example of something oftentimes is going to be in black, and then or a trace so that you have an example. Or it might be if in the pattern you get to a point where maybe it doesn't always follow the pattern because it's just written in. You really just have to look at the instructions where it says to write the slopes and the y-intercepts. And since those blanks are already filled in for you, there's nothing to do.
What about in the companion? This is page 2, right? So you would have already gone through this if they wanted a video, like, because you have a video and you're walking through it, so you probably said that in your video. So that could be one place if you feel like you need something else, right?
That's true.
And then so basically for the vertical lines in any of the lessons, because I'm looking at monomials and I have complex in front of me, the X value could be anything on that line. So no matter what that X value is, the slope is always going to be infinity for a vertical line, and as long as so if it's X equals 0,
Now it has a y-intercept, although it's kind of a weird, I mean, it's kind of
infinite?
weird,
Is
right?
it
Because it's
empty?
like every point is a y-intercept. So I would still say, I would probably still say it's really not applicable because there's not one y-intercept. So
Okay.
we wouldn't normally talk about a vertical line having a y-intercept, even in the case of x equals 0, because it's every point.
Okay. So I
And you
like
could-
that there's in the complex it's a negative number, but then in the monomials it's a positive number to show the differences, that it could be anywhere on that x-axis. Okay, thanks.
You're welcome. Right. So moving on to our day 3, and we are encouraging you to continue with the flashcards, but also to consider some quick flip arithmetic games. heard somebody recently say something that we all knew, but perhaps had not said, that a lot of traditional curricula, when they say math, what they really mean is arithmetic, right? That most of your elementary curricula are arithmetic curricula. The math map is a mathematics curriculum, right? And so arithmetic is a portion of mathematics, but we obviously are doing a lot more than just arithmetic in the math map. And so those quick flip arithmetic games are an opportunity to practice the arithmetic, to practice the calculations in a fun way, to build up your ability to compute when necessary. We've said this before, right? That the importance behind being able to calculate is that you need to be able to know how to calculate and to calculate accurately so that you can see the patterns in mathematics, right? That there are going to be, right, elements of mathematics that require us to go, oh, right, I see this pattern. I've seen that if I say 3 plus 3 is 6, and 4 plus 4 is 8, and 102 plus 102 is 204. And I've done this so many times that I think, oh, it's the same thing as multiplying by 2. It's easier to multiply by 2, right? If I said 3,642, it's easier to multiply by 2. So if I've added those two numbers enough that I then say I've seen the pattern, and now I'm going to generalize this to saying I can multiply by 2. It's the same thing, right? That's where the power of knowing how to calculate comes in, and that's where it's so helpful. Versus we don't necessarily need to teach calculation like it was taught 200 years ago, where you had to do all of your calculations by hand for your accounting and your engineering and so forth, right? That the value of our calculations are that they're going to unlock the ability to see patterns. And so arithmetic matters. I am not saying that it doesn't, but we're trying to see arithmetic within the context of mathematics and not as an equal to mathematics. And so that's why, if you have younger learners, if you are still developing those calculation skills, which might be true of a 50-something-year-old, right? That we may still be practicing our calculation skills, right? That doing so through games is a great way to do that. And the quick flip arithmetic games gives us the opportunity to really have almost an infinite number. And I say infinite because there is an infinite number, but there's a finite number, right? If you want to practice 4-digit addition, there's a finite number of sums. Just saying, right? There's a finite number of sums, but there's a lot of them. Right? There's a lot of them. And so quick flip arithmetic gives you access to all of them, not all at once, but to all of those sums that you can practice. So coming back to our I-cubed page, our memoria and arrangement page, this is where we're practicing our core habits of memoria, and we're seeing our grammar in context, right? In an arrangement that helps us to see where the pieces fit together. So one of the things I would encourage you to ask your students when you get to the memorize idea of our names, right? Memorizing. As we look at this page, ask them, what are some things that you want to memorize? When we memorize, we want to make sure that we get the order. We want to be exact. We don't want to approximate, right? We want to say we know it exactly. So if I said I was going to memorize everybody's birthdays, right? That means that I know the month, the day, and the year, and the name of the person, right? I want to be exact. I don't just want to go, oh, well, some people were born in February and some people were born in March. That's not memorizing, right? That would be maybe remembering, right? Because I'm kind of jumbling some things up and it may not be exact. So taking a look at the page and saying, what are some things on this page that we could memorize? So we might want to memorize point slope form, slope intercept form, the standard form. We might want to memorize the definition of slope. We might say, I want to memorize the midpoint formula for 2D or the distance formula for 1D, right? Things that are formulas or definitions, right? So I might look here and I think, okay, so here, is this a definition or a formula? It's kind of both, but that might be something that I want to memorize. I want to have it exactly, right? I might want to memorize a process. So when it comes to graphing, I might want to say, okay, I want to label my x-intercept and my y-intercept, and then I'm going to graph my line. That's a process that I need to do in the same order every time, so I'm going to memorize it. Remembering might include some things that we've memorized, but it might mean that every time I do it, it might be a little bit different. So for example, the diagram of the first quadrant, I might not do it exactly the same way every time. I might not exactly put quadrant 1 up in the top right. I might write it here, right? Or he might write quadrant 2 here. I might sometimes include the values of x, and I might sometimes not. Sometimes I might just put the x-axis. Sometimes I might put all of the description of the axis. So that's an idea about remembering. It might pull together things that I have memorized, right? But it's not always going to be exactly the same, right? So images and labels or the details of a process, right? So the process, I might memorize my steps, but the details of those processes might be something that I remember, right? I don't have to memorize word for word what I do, but I remember what I'm doing. And so that's how I think of the difference between memorization and remembering. Both of them are memoria. But memorization is where we're having to be very intentional because we don't want to change it, right? We want to memorize it exactly the way that it is. Does anybody have any questions about that? Or a different way that they see it, right? This doesn't have to be that I have the only way to, but for me and how I worked with my students, that was how I differentiated the two.
I had shared in the chat about the quadrant numbers because I remember that was one of the first things I got the Challenge 8 kiddos to memorize or just ask them if they knew them first. And a lot of them didn't know which quadrant was which. They would start on this side instead of on this side to do the quadrant numbers. And so, I mean, that was something really easy for them to memorize because they could just draw across and then, remember where to put the numbers. But it was really helpful as we got into more detailed things and they needed to know those quadrant numbers, or when we got to the unit circle and it was helpful to know the quadrant numbers, or I guess they called them something different then, but just because I feel like we think some things are so easy, like they know that, but the Challenge 8 kids that I had that year didn't know that. And so not taking those things for granted.
Well, and even with the quadrants, just knowing like in the X, Y, X comma Y thing, which one's positive, which one's negative, each quadrant, so first they memorize 1, 2, 3, 4, and then they go to plus, plus, minus, plus, minus, minus, plus, minus, so that it's, it's building on that thing so that when they get to the unit circle and they're starting to do trigonometry, they don't need to learn that stuff anymore. So
interesting. So I have a question about the graph.
Mm-hmm.
I actually think I might have just answered my question, but I'm going to ask it anyway because maybe it'll help others. Where it says graphing linear equations using a table of values and then using a point and the slope. Why? Okay, no, I don't know the answer. Why are those labeled as two different ways when like it's XY and X? They're always, even the negative CD on the left is still an XY coordinate. Can
So
you like, how do I
yeah,
explain
so
the difference?
the difference is that let me turn on my pen. So I would say here's the difference. Let's say I have y equals 4x plus 3. If I was going to use 2 points to graph this line, Lee always likes to have the verification point. I'm not going to talk about that. I'm just going to say I'm going to look at my x and my y intercept, because my x intercept is where y equals 0. So if I go 0 equals 4x plus 3, negative 3 equals 4x, x equals negative 3/4. So there's 1 point. I can go to negative 3/4, 0, and there's one of my points. The other point is going to be where x equals 0. And so I would have y equals 4 times 0 plus 3 equals 3. And so now if I go to 0, 1, well, let's see, try to get my scale kind of right here. Here's 3. And now I draw my 2 points. I've just done the first method where I find 2 points and I graph those 2 points. Alternatively,
Mhm.
I'm going to just use a different color ink here. Alternatively, I could say, okay, I'm going to use these 2 pieces of information. And I know that my y-intercept is 3. So I didn't necessarily have to solve for that, but I just wanted to show that we're looking at the 2 points where x equals 0 and then y equals 0. So this is my y-intercept. It's at 3. Instead of solving for another point, I can go, okay, my slope is 4. So I can either go right 1, up 4, or I can go down 4 and back 1. So if I go down 4, 1, 2, 3, 4, back 1, and notice I'm graphing the same line, but I did it graphically because I just counted on my graph. I didn't actually calculate that second point.
Got it. So this is about
Now,
process.
it's just 2 different processes. Same line, same information. It just is going to give me 2 different ways that I could graph that line.
Got it. Okay,
Now,
so this is about just choosing which process to use, not necessarily that there's any difference in the name of the points or the name of the formula.
correct.
Okay. And B
Now,
is automatically Y. I think that's news to me.
yeah, B is your y-intercept. So if you see here, right, when I substitute in my 0 for x, I'm always going to get that constant on the
Yep.
end. And so that's
Okay.
always going to be my y-intercept.
Okay. I think I did know that.
Now,
Thank you.
as your students, as we live in this world where we talk about data science, and we talk more and more about how we analyze data, if you have students that are working with data sets, so I'm thinking older students, even college age students that are doing some kind of analysis with large data sets, sometimes we end up with points that are nowhere near the origin, right? So our data values might not have, right? So it may make more sense for us if we wanted to graph a line to use 2 points that maybe aren't calculated with the intercepts, but maybe are 2 points that we know, right? That we see, I'm just going to draw, like this might be, our origin might be way down here. And so if we were to graph our intercepts, they may be sort of, but we're working with data values that are all up here. And so it might make more sense to find 2 points that are within your data range in order to draw your graph, because you want to be looking at your data up here. So There are cases, not that we're looking at here, not that anybody's doing yet in the math map, but I just want to point that out, that if you're looking at students who are dealing with any kind of data analysis, there may be times where we're not close to the origin with our data values. And so we would just want to use our 2 points, and they may be different than the points that we choose here, because we would want to pick them, out where our data is.
And so, Kirsty, in that example where the rectangle is, up and to the left, that would be where we would use the verifying points.
You could, I
find
mean,
our line?
you always only need 2 points to graph a line.
Okay.
And so
So
that's just Lee's way of saying, if I pick a point in between or pick another point, it's just one more way that I can make sure that I calculated correctly. Because, right, I have a kind of a 50% chance of making a mistake if I only have 2 points, but maybe a 30% chance of making a mistake if I have 3 points, right? I'm less likely to get the wrong line. So that's why she likes to pick that verifying point. If you live dangerously like me, you would just pick 2 points and be good. But
Okay.
that's why Lee was an engineer and I was not.
Okay, can I ask one more question about this page?
Yep.
I don't want to keep you here too long. At the very top, it says forms of linear equations, and it gives you 3 different forms. I have always memorized y equals mx plus b. The other 2, I must say I'm familiar with point slope, but the standard is news to me. Would you recommend, I guess I should ask 2 questions. 1, are all of these forms of these linear equations somewhere in the flashcards? And then 2, would you recommend we memorize all of them?
I don't think they're in the flashcards yet. I am kind of sort of in the process of, I need to get in the process because I'm a little bit behind. I need to be in the process of writing the algebra flashcard deck. And so they will likely be in the algebra flashcard deck. So that is coming, not quite ready yet. Yes, because, and the reason why I would say that it is worthwhile knowing all 3 forms, again, if I have data that is not near the origin, my point slope form may be much more useful than the slope intercept form. Okay.
Yeah, that makes sense.
Algebraically, it is easy to solve for the slope intercept form. Right. So oftentimes we may start here and end up here.
I'm sorry, I was looking down. Start where and end up where?
Start with our point slope form and end with our slope intercept form, because
Gotcha.
it's fairly easy to solve for y and we end up with our slope intercept form once we put values in for x1 and y1.
Okay.
The standard form, what you need to know here is that a, b, and c are all integers. And so that's what makes this different, because I could have said that y equals 1/3 x minus 0.7. And that is true, right? And I can graph that line and I can understand that line. But if I was to put that into standard form, I can't have any fractions. So I would actually multiply both sides by 10, by 30, and I would have 30y equals 10x minus 7. And then I'd bring everything over to one side and I'd have negative 10x plus 30y plus 7 equals 0. And then for good form, I would usually change this to 10x minus 30y minus 7, 30 equals 0, because I like having my positives first. This form is useful, and we're not really going to get into this. Maybe in the upper challenge years, we'll start to see this, but understanding the standard form of an equation is going to be useful in finding parallel lines, normal lines, doing some different things, it are comparatively easier with standard form. So again, not anything that our students are doing now, but being familiar, being able to write an equation in standard form is going to stand them in good stead for future work that they may want to do in mathematics.
Okay.
Yeah.
That's very helpful. And can I just say that this is the first time that I've ever related all of those three things to the same linear equation. I was always guessing when to apply which of these, formulas based on whatever I was given. This is the first time I'm realizing these are all just three different ways of looking at the same thing. So
And that's beautiful, Nicole. I'm excited because that's what we're talking about with the classical method, right? Is that we're saying that the didactic instruction that people have been getting for decades has been disjointed. So you were taught one method for this equation and a different method for this equation without anybody ever really saying, look, it's the same thing. You're doing the same thing. We're just expressing it in different ways. And so that's why we keep pushing back on providing more didactic instruction, right? People keep asking us, well, we want a script. We want you to explain this. And we keep pushing back and going, no, because we want you to wrestle with these things. We want, and it's going to come at a different point for different people.
Yes.
Right?
Yes, because and can I just say I'm sorry to be talking so much today. I also am using the books that I used last year. And last year, when I got to something that I didn't understand, I would highlight it with a green highlighter. So now this year I'm coming back to it and I'm saying, oh, this is something that I didn't understand. Let me ask about it now that I can. Right. So I thought at the time I got to go figure this out on my own because she's way ahead of me. But if we look at it long term, this may actually be a good process that our kids are going to. They may through as well. They may not get it the first year or even the second year. But if we kind of use the same frames or the same charts, they can go back and say, I didn't understand this last year. Let me see if I can spend a little bit more time on it this time. And so then they don't actually miss it. They just take more time to get it, which is helpful for me because I'm always nervous when I'm missing something.
That's great. That's a beautiful testimony. All right. Well, I know we are close on time, so I'm going to just quickly say here's page 3. We're looking at horizontal and vertical line tests. Hopefully that feels like accessible. Day 4, we're looking at the careful calculations. So last week we talked about assessing for speed over 4 days. This week I'm going to give you an idea for assessing for accuracy. So on day 1, you could have your students go through and then just go through and mark the ones they got wrong. On day 2, go through and correct the ones they got wrong. On day 3, say why, right? Review your errors and know why you got it wrong and what the correct one is. And day 4, aim for no errors. So again, taking those careful calculations pages, especially if you're using them later on, right? Maybe over a break. So as we're looking at fall breaks in some communities, you may want to pull out some of those careful calculations pages. And here's a way that you could use them over the course of 4 days to assess for accuracy or for speed. And then we're going to continue to see, we've got vectors on page 4. And I think it's exciting because the things that you learned about vectors in 1D are true. We just now have 2 coordinates. And so if your students become more confident with the language of vectors, what they learn is going to translate through all the dimensions. Just a reminder of the support that we have for you, continuing to work together, asking good questions, utilizing the resources. It always hurts me when we get people that say there's not enough support for the book, for the math map, because we really do want people to feel well supported. And so if there's something that you need that we're not providing, or you don't know where to find it, please do let us know. You can email us at the Math Map at Classical Conversations, and chances are that the resource does exist and we can help connect you with it. Are there other questions that anybody's been holding on to or would like to go back to? I wanted to honor your time, so that's why I wanted to kind of go through those last couple of slides, but always have time for questions. Nicole.
Could you go back to that previous slide right quick? So I wanted to grab a screenshot of it and I was just a second too slow. Okay, thanks. And then my question is from page 3, the range one. I'm looking at the complex, so I think it may be a slightly different problem. But we really struggled trying to figure out, we keep getting the wrong part shaded. Like we're shading whatever part we're shading, it's like the opposite of that is what the answer is. And I can't figure out why.
Okay, so when we here, right, we're always, if it's y is greater than, I'm going to go to our last slide here. And I'm going to, if you want to give me a specific question from your booklet, I'm happy to talk about that.
Sure.
Look at Babs. Isn't she just amazing?
Yes, you're great. That's amazing. Yes.
So as we look at this here, right? So there's two things we're going to look at. Let me turn this back to my pen. Oops. So y is greater than or equal to the absolute value of x plus 3 plus 2. So we're going to look first here, and we're going to say it's or equals. So that tells us it's a solid line, not a dashed line. It means that the line is part of the border. So that's step 1, is figure out what your line is. Step 2 is whatever that symbol is, we're going to look at the related equation. So for a minute, don't worry about less than, greater than, just say if it was equals, this is what I would be graphing, is x plus 3, absolute value of x plus 3 plus 2. And so now I might say, okay, well, what happens when x equals 0, when y equals 0, right? And because it's absolute value, we see that we're going to have this shape. So I'm going to need more than just one point. And so I might say, well, let's look at x equals 1 and x equals -1, right? Because if it's absolute value, I'm going to look at the two different options. So if x is 0, y is 3 plus 2 or 5. When y is 0, it's never 0. So it's not, I'm just going to put here, there's none. There's no x-intercept. So now I'm going to look at my other 2 points here for x equals 1 and x equals -1. And I'm going to say, okay, well, when x is 1, it's 1 plus 3 is 4. The absolute value of 4 is 4 plus 2 is 6. And here I've got my x equals -1. And if I put -1 in, I get -1 and 3 is 2. The absolute value of 2 is 2 plus 2 is 4. So y equals 4. And so I might then say, okay, well, let's graph these and see if this is enough points. So at x equals 0, I'm up here at 5. At x equals 1, I went even farther up, and at x equals -1, I had 4. And so I'm not going to lie, with absolute value, you kind of have to know that there's something weird going on. So I might go, okay, well, that didn't help me because all I got was a line. So I now need to find out where does this start to go the other way. So I might say, I see these values are going up, right? I'm going to look and see how far down they go. So I might then keep going with x equals -2, x equals -3, x equals -4. So when it's -2, we get 3. At -3, I get 2. At -4, I get 3. And so I see this pattern happening here. And so now I can go, well, here's my -2 is 3, my 3 is 2, and so forth. And I'm plotted enough points that now could essentially do the two lines, see that they intersect here and cross off this part. So because it's positive. So that's why Lee gave these pictures here, because these absolute values are a little bit, if you're not familiar with them, they're a little bit squirrelier to graph. But once I have my lines graphed, now my next question, step 3, is to go back and look at the inequality part. And it says greater than. So this tells me that I'm going to shade above. So I need to be above that line, because that's where my y value is greater. Right? There's no magic, it's just above the line, right? Because if you think about this, if I look at any particular point, right, just this point, everything up here is greater. If I was to look at this x value, everything up here is greater. If I look at this x value here, the y values up here are greater. And so when I do that for every single point, I'm going to end up shading in the whole thing.
Okay. So is it fair to say that in learning this from scratch, this is just something that, like, is there, okay, so I'm trying to remember how we figured out that there was something wonky about the absolute value. Is there a place where we talk about that here, or is that something that we just may have observed?
Well, you're going to see, so that it is in chart 9 that we talk about the absolute value. And we talk about, we see the image of the absolute value giving us the x, and that it's this piecewise function. So we're going to talk about the absolute value. You're going to see it over and over again. It's going to be in lesson 9. Don't know if it pops up in 11. It might pop up in 11. You should see it in 17. You're going to see it. You might see it in 18. I think we talked about it in 18. You're going to see the absolute value function pop up in multiple places, because it's what we use as our example of a piecewise function. And so if you look on chart 9, it says that where x is greater than or equal to 0, it's y equals x. Where x is less than or equal to 0, it's y equals negative x. All right, and so that's where
Gotcha.
we see this happening. So that's why we call it our piecewise example. And so you're going to see us revisit that in several lessons over the course of the year. Now, eventually, certainly not this year, eventually your student is going to see this, and they're going to go, wait a minute, if my parent function is this, and I translate this is from lesson 18, right? And I translate this with -3, 2, I get the function x plus 3 plus 2. And we see that if this was my original graph, then I'm translating it left 3 and up 2. So I'm going 1, 2, 3, 1, 2, and then I draw it there. So that's what we're going to be looking at in lesson 18. So again, they're not going to, their first year, their second year, they may not be making that connection. But over the course of many years, they should start to see that connection.
So would it
Gotcha.
be accurate, Chrissy, to say that all absolute value graphs would have that some kind of V?
Yes.
So I'm looking for a V somewhere in
Yes.
that thing.
Mhm.
Okay.
And that's why Lee gave the students these graphs there, because she knows that these are challenging for a first year student to be able to move and graph and do that. But eventually they're going to take what they've seen here, what they're seeing in lesson 18, what they're seeing in other lessons, and they're going to go, oh, all I'm doing is moving this around or dilating it, making it a little bit narrower, making it wider, or flipping it, right? If it was negative, it would flip it. So those are the things we're going to be studying in lesson 18. So again, do you get that your first year? Absolutely not. Your second year, probably not. Your third year, maybe you start to make that connection. But fourth year, fifth year, you should definitely be starting to see that that's what you're doing here. So, did that help any, Nicole? Because this is hard, right? So we kind of talked
Very
more
much.
about the absolute value function than the graphing, but just think if it's greater than, it's going to be above. If it's less than, it's going to be below. If you're talking about y, if it's right, so if you think here, y is greater than is going to be above, y less than going to be below. If we were thinking about x greater than is going to be to the right, x less than is going to be to the left.
Gotcha. Yes, that's very helpful. Just hoping I remember it when we get to week 9 this year.
We'll grab a screenshot.
Nope, not.
And I don't know if that's really weird because I wrote something on one screen that showed up. Did the green and the blue show up, Babs?
Yes.
Okay.
Mm-hmm.
All right. Wanted to make sure. All right. Any other questions?
I've got some questions and things to go over. So I've been wrestling a lot with domains, and I'm kind of struggling with that. So mine are kind of more domain, even going back to lesson 2. I've referred that chart many times over the last few weeks. I've got a few different domain questions. I think I'm finally maybe understanding it, maybe not. I don't know. So on the monomials back in booklet 6, I have a few questions and a couple of these domain questions, and that might help answer my questions, or maybe not. We'll see
Okay.
how it goes. But on the monomials in booklet 6 on page 6, if you could just help me here. Halfway through the page, we talk about division and we talk about dividing. And we're giving the domains of the numerators and the denominators. One of the numerators domains is 8x. And that you have that as a natural. So can you help me understand how that's a natural?
I think that Lee, yeah, that whole one doesn't really make any sense to me. I'm just
Okay.
not gonna lie, because
Okay. Oops.
I think that she's thinking in terms there that the 8 is a natural. So she's
Gotcha.
not
Okay.
necessarily thinking about the domain of x. She's just going, well, 8's natural. And the bottom, those are, because the square root of 1 is natural, those are all naturals too.
Okay.
So yeah, I would say that whole row probably needs to be reworked.
Okay.
And we will ask Lee. Babs is even now sending a message to Lee saying, hey, can we talk about reworking this one so it's a little more straightforward.
Okay.
So
that helps. And then so booklet 4, if we go back to booklet 4. So I've been working on this for a while, as you can tell. I'm back in monomials booklet 4, page 14. Sorry, Babs, that's where I'm going. There is page 14. And again, kind of in that middle section, it talks about label the term's narrowest domain. The fourth one down, it is 2 minus 8x minus parentheses a negative 2.5 plus 6x. They have that as being a z, which would be your integers. But how is 2.5 an integer?
I would say that's another error.
Okay. Okay.
And I'm sorry, like I wish Lee wishes, our editors wish, like we all wish that there weren't these errors, because we know they trip people up. But yes, you're absolutely correct that would be, again, with the x in there, it's kind of confusing, because what do we, normally we would think we need to think about what is the domain of x. So, but if we're just considering the numbers in there, it should be rationals.
It should be rationals. Okay, yep. So the quotient, yep. Okay, that makes sense. Okay, so then I've been kind of going back. So it's kind of been a good thing though, because I've really had to go back and wrestle with the whole idea of domains and how they work. And sometimes with some of these questions, I'm going to the domains page on the I1 page and try to figure out some of that from the I1 page. I've kind of got some of the definitions down. So I'm just kind of, maybe this is an aha moment for me or something I'm kind of, I've been wrestling with, like I said. So transcendentals aren't actually, I always thought like transcendental is like this big thing at the end, we get to know all the numbers, but really transcendentals are kind of like tucked in. They're a type of irrational, a type of a real number. Is that a correct statement?
It is a correct. Well, they are actually complex as well as real. So there are complex transcendental numbers. There are normally the real, the transcendentals that we normally think of are real numbers.
Okay.
But the transcendentals actually transcend the reals, and you can find them in the complex numbers as well as being this subset of irrational numbers.
Okay.
They're weird. I mean, there's more transcendental numbers than there are like other numbers. Like there's so many of them.
Okay.
But we don't actually, there's more irrational numbers than there are rationals. And then the transcendental numbers, there's so many of them, but we think of like just a few, right? But there's so many of them out there. And then one of the reasons why we call it transcendentals is not only because we're saying, okay, let's think about equations. So if you look at the polynomials and the binomials, right, and the expressions, and we say we're using algebraic numbers, what we're saying is that we're really going to look for numbers that are solutions to sort of nice polynomials, where they're solutions to these polynomials. Whereas transcendental numbers, there is no polynomial that will have pi as its solution, right? Necessarily. I mean, that's a nice polynomial. But then also in that transcendental year, we want to think about the transcendental virtues of truth, beauty, and goodness, right? So it's not just the transcendental year of like, oh, you're going to see all these different numbers. There is this aspect of, hey, we want you to think about where do these numbers show up in the things that you've been doing. But we also now are saying, okay, take all that you've been doing, and we want to take all of that and we want to integrate it and we want to put it together. We really, this looking for the unseen, the seeing the unseen that we've been pointing you to for 6, 11, however many years, we want you to pull that together and really say, okay, well, all of your math education up to this point, how are you seeing truth, right? How have you discovered beauty? Where is the goodness in mathematics? And so that transcendentals kind of has two definitions when we're thinking about the domain, the math map domain of transcendentals.
Okay. Thank you for that explanation. That helps so much. I do want to say I did go to the companion, and there was that great tree there that broke things down, and that really was helpful too. So I really appreciate that, because that helped me in my wrestling with things. So thank you.
Oh, good.
And then I do have a couple, if you don't mind, just a couple kind of errors that if I can just kind of get clarification on right now, if that's okay too, or okay. Back in booklet 6 on page 4, I know there was one error there already, but yesterday in class when we went through the class, they told me that where is it? That 26 is not 3 cubed.
No, it is not.
Yep, so it should be 27, right?
It should be 27.
Okay, yep, okay. And then on booklet 5, I'm sorry, but on booklet 5, page 13 at the bottom, and let's see here, booklet in the monomials, and maybe this is just me. My daughter and I wrestled with this one this morning for a little bit too, trying to kind of figure this one out. So we've just been wrestling a lot today with different things. But yeah, booklet 5, the bottom of page 13, it has 7 plus 7 over 7 plus 2 sevenths A. And I don't know if that should be just multiplication versus addition there. Or did I might have been corrected. I may have missed that. I apologize for that.
Yeah, that one there, that 7 over 7 should just go away. It should just be 7 plus 2 sevenths times A.
Okay.
And then we see it becomes the 49 over 7 plus 2 7. So I would just get rid of the 7 over 7 or multiply it, right?
I was
So
going
you
to say
can either,
multiply because then it follows the pattern of the two above it. If we multiply,
does
because
follow,
the two are
yes.
multiplied, and then this is added, I'm like, so where does that doesn't follow the pattern of what we've
it doesn't.
used
That
before? Okay.
excellent. Yeah. So
Okay.
there you go. Just follow the pattern and it's multiplied, and that's perfect. And that's exactly what we want to be doing, is following that pattern.
Okay. I appreciate this so much. Thank you so much for answering questions. Thank you for
Oh,
taking
you're
your time.
welcome.
And thanks, Babs, for all your help too. I appreciate that too.
I recognize both of those. I think somebody has reported them, but I don't think they've made it to the errata yet. So I think they're like in transition.
Mhm.
So it's good to bring them up here because then everybody can be aware of them and not have to wait for the errata.
Okay, I have another I have a question and a statement.
Okay.
So I'm looking at week 6 as well, but it's in the fractions domain. And I'm looking at page 4. And I was really proud of my son for catching this, but then when I looked at the solutions, he was wrong, and I'm not sure if he is. So in the top, I'm trying to get my left from my right, where it says trace and compare, and it says 1/4 is, greater than, it's supposed to be 1/5 is greater than 1/6 equals 1 over infinity. That whole line, it's page 4 of week 6 of the fractions. It's actually the top of that page. So that what you just put up, Babs, is the right page, but it's the bottom of the page, and I'm referring to the top of the page. Anyway, my son was like, "Mommy, this one that's 1/5 and the one that's 1/6, they look the same. They look like they're the same size." And he said, "Oh, they're trying to trick me. It is the same size because there's 6 pieces, and so it's equal to." And it turns out that middle pi is where I think it's supposed to be 1/5, but it's actually a picture of 1/6, which makes it
Yes.
equal to the 1/6 next to it, which made the 0 at the end make no sense to us. We were like,
Makes
what?
no sense. Yes. Yeah, it
Um,
is supposed to be 1/5 in the middle, and the wrong image got stuck in there. So
okay,
we
great.
weren't really trying to trick him.
Well, he was proud of himself. He was like, they tried to trick me and I got it. So he put equal to, and where it says 1/6 equals 1/6, as far as the pictures are concerned, he put equals instead of greater than. But then of course the 0 didn't make any sense. And I was like, just trace the 0, we'll figure it out later, right? So I just thought I would point that out. Yeah. And there was one other one, but I didn't highlight it, so I'm not going to worry about that. 2 things I wanted to say just as a quick testimony. One, someone text messaged me a picture of something in monomials and was like, "Hey, can you help me with this?" And my initial response was, "No, I'm not a math person. I don't know why you're asking me. You need to email the math at classicalconversations.com." But then I said, let me look at it and I'll let you know. And so I ended up making a video explaining the I equals, it was something that said realize the denominator. And I was like, realize the denominator? I don't even know what that means. So after I studied it, I was able to explain it. I was able to say, oh, like the pattern is the square root of something times the square root of that same thing is that thing. So now we're just trying to make sure that we get rid of the I and basically make it a 1. So I went through all of that and I was super proud of myself, you guys. I was so proud of myself. And that I went to my kids, my 11-year-old and my 13-year-old, and I go, you guys, I'm becoming a math person. And I start to explain it to them. And I say, and the directions say, realize the denominator. And I didn't know what that meant. And my 13-year-old goes, it means make the denominator a real number. And I was like, okay, whatever. Like, okay, so you knew that. Right. So then I go through it, and then my 11-year-old comes in, I don't know, 10 minutes later, and I'm all excited, like, let me tell you what I did. And I told him, and I said, it says realize the denominator, but I didn't really know what that meant. And he goes, it means make the denominator a real number. I was like, wait a minute. what is going on here? Both of my kids, 11 and 9, I mean, no, not do have a 9-year-old, 11 and 13, both immediately knew what realize the denominator meant, and I did not. And I was like, I want to be a little bit, like, what is wrong with me? I'm way older than y'all. But instead, I was just really, really excited and proud of them for, I guess, paying attention, right? Like, I don't know, but just recognizing that this is actually working, and they speak the language better than I do now. And that's really exciting.
Well,
And then
thank
the
you.
last
That's
thing I want to
encouraging.
say is this week we're doing division, and we, for the first time, read the contribution to the conversation together. And with everything that's going on in our world today, it was so like punch in the gut, real. And I just had to acknowledge the providence of God that we just decided to read it together this time and talk about division and how we see it, like how we see this mathematical idea playing out in our society today. And it was fabulous. And I just want to say thank you about that.
God is good.
It is.
I have some questions too.
Okay.
My daughter was struggling with in book 6, the 1/10 to the negative first power equaling 10 to the first power. And now we're seeing that again in book 7, where we're switching the denominator to the numerator and the numerator to the denominator. I understand like flip and negate, but is there a better way, a more mathematical way to explain that to her?
Sure. So, if we, I'm gonna figure out, I've drawn apparently with the PowerPoint tools, and I have drawn with the Zoom tools. So I've got to figure out how to erase the Zoom stuff. Oh, here we go. Clear all drawings. There we go. Okay. I think that the easiest way for you to work through this is to think about, is to look at it vertically and think about exponentiation that way. So let's say that I have, no, you go away. Oh, there we go. And now I can do it this way. Okay. So let's say I have 10. And I say that's the first power of 10, right? I have 1, 10. If I multiply both sides by 10, right, I end up with, 10 times 10 is 10 squared is 100. If I keep that process up, right, I take my 10 times 10 and I multiply it by 10, I get 10 cubed or 1000. And we feel pretty comfortable going up the ladder. Now think about going down, right? That here, if I had divided, if I took my 10 times 10 times 10 and I divide that by 10, I'm left with 10 times 10. So 10 cubed divided by 10 is 10 squared. 1000 divided by 10 is 100. If I do that again, right? So I take my 10 times 10 divided by 10, I get my 10, or my first power of 10, there's my 10. Now let's go another step. So now I take my 10 divided by 10, and I see that's 1, right? So I subtract 1. Notice my pattern is I'm subtracting 1. So that's my 0th power of 10, and which is 1. Here, I guess I'm kind of writing this twice, but so now I take my 1 divided by 10. I subtract 1, right? I'm going to write it this way so we can see. And that gives me my fraction. So now I take my 1 divided by 10 and I divide it by 10 again. And I subtract 1 and I simplify that, right? And I get 100. So going up, I'm multiplying by a power of 10. Going down, I'm dividing by a power of 10. And I think that helps us to see the pattern, like why are my negatives 1 over? So now I can take that, right, the negative first power of 10, and I see that that's 1 over 10. Well, if I had 1 over that, that's 1 over 1/10. If I multiply this by 10 over 10, my 10s cancel and I'm left with 10 over 1, which is 10, which is the first power of 10. And we could do that with any of those powers to see why, when I want to change from the numerator to the denominator, I can use those reciprocals, right? The negative tells us that it's going to be the reciprocal of that. Because if I looked at, like, let's look at the negative 2 power of 10, I can see this as 10 squared, right? And then the reciprocal of it. And similarly, if I had 1 over the negative 10 power, I could say, well, this is 1 over 10 squared, but it's reciprocal, right? So I'm kind of have a double reciprocal there. And so that's why I can end up with my 10 squared. Does that help?
Can I ask a question about this?
Yeah.
So, Dr. Kirsty, you just explained this to us didactically. Can you help us, like maybe walk us through a process of how we would help our children discover this or get to this using questions that where they would discover it on their own using the charts or whatever resources? Or would we have to go watch a video or put them in front of a video or whatever to explain this?
No, so I would say ask your students. So let's think you hadn't seen this, and you could say, okay, well, let's see if we can find a pattern. And I think, I don't know. I'm going to just say this. I don't know whether I would order it left to right. It doesn't matter, right? So you could say, let's connect this back to place value, because if you remember with place value, that's where we maybe first saw these negatives. Right? When we looked at place value, we saw this pattern. So I think I might have started here and said, okay, well, where have we seen all of these values ordered this way? Well, we did see it with place value. Let's go back and look at chart 2 and let's just copy this and let's talk about what's happening, right? And so then I might say, what do you know about exponents? And they might say, well, I know an exponent means I'm using it that many times as a factor. So I have no 10s as a factor. That's 1. I have 1 10 as a factor. I have 2 10s as a factor. I have 3 10s as a factor, right? So I could help them maybe to see that my positive exponents are giving me the number of factors that I have here. Okay, so I'm still maybe not seeing, let me just send a quick text. So we start here, and I still might not be seeing what those negatives do, right? Because I'm trying to get to what does this negative mean. So I come back and I say, okay, what did we do going from right to left? Is there a pattern there? And it might take a minute, but hopefully your students see that going right to left, we're multiplying not by 10, by 2, by 10, right? I'm multiplying by 10 each time. And so I might play with this, right? And this is cubed, not fourth, right? And I might say, okay, well, let's try this, right, with different numbers. We could do this with 2s. We could do this as 3s. I'm multiplying by 2 every time. I'm multiplying by 3 every time, so that we practice multiplying as we go to the left and help them to see that pattern as we go to the left. Then after we all feel like we've sort of seen this pattern going to the left, I might say, okay, well, now I want you to start out here and I want you to move to the right. Right? What do I do to go from 10 times 10 times 10 to 10 times 10? How could I explain that? And that's where I could, right? We could think about inverse relationships. Well, if going left, I was multiplying. What is my inverse when I go right? Right? So I might help them to think through that. Well, maybe I need to divide. Okay, well, let's check and see if that works. So 10 times 10 times 10 divided by 10 equals 10 times 10. That works. 10 times 10 divided by 10 equals 10. That works. 10 divided by 10 equals 1. That works. And if I'd written this out, let's say I'd written this out for the twos. All right, so I had 1, 2, 2 times 2, 2 times 2 times 2, 2 times 2 times 2 times 2, right? If I'd written this out for the twos, I could do the same thing. Going to the right, I'm multiplying by 2. Going to the left, I'm dividing by 2, right? So now I've picked up this pattern of multiplying and dividing, and I've done it with my positive indexes, and I'm feeling somewhat confident. Now I can say, okay, well, let's see if we can see how this pattern might continue going the other way. So since I started out here, let's see if we can continue going this way, right? This is supposed to be a 10, by the way. What is 1 divided by 10? It's 1/10. What's 1/10 divided by 10? That might take them a minute because fractions are hard, but they might get 100. What's 100th divided by 10? It's 1,000. Now this is where if you're looking at that place value chart, it's going to be helpful because it says on there tenths, hundredths, and so forth. So now I can match it up and I can say, oh, yep, that matches the words, right? The tenths, the hundredths, the thousandths, and so forth. So I can use this part here to see that I'm writing this correctly as I'm dividing by 10. Now I go, oh, well, these have to be equal, right? And I go, oh, so the negatives are kind of telling me I'm dividing, right? That's the number of times I have that as a divisor. They might notice that if the positives, this is the number of times it says a factor. Somebody might say the negatives are the number of times it's a divisor. They might say, oh, wait, when it's negative, it goes in the denominator. That's okay too. They might say, oh, it's a reciprocal. There's a lot of different ways that they could do that. But I think that's how I would work with my students to see the pattern first, then to add the notation, and then to add the words, right? So we're going to go concrete, look at the pattern. And like I said, we can do this with any number, right? So we're familiar with the tenths, but we could do it, right? If I divide by 2, I get a half. If I divide by 2, I get a fourth. If I divide by 2, I get an eighth. Those are on that place value chart too, so I can see that this is, right, the negative first power of 2, the negative second power of 2, the negative 3 power of 2, third power of 2. And so I can just keep doing this with numbers so that they see this pattern of multiplying to the left, dividing to the right, right? If you then wanted to say, well, let's look at this vertically, that might help them think I'm multiplying up and I'm dividing down, right? It doesn't really matter. We just want to see the pattern. I connected it to place value because that might be something that already feels a little bit familiar, right? Ladders might feel familiar because the idea of multiplying up and dividing down. But my goal is to look for a pattern first, right? Then I'm going to connect it to an unfamiliar notation. And then I'm going to see if I can find the words that are going to describe it and make it more abstract. And it's okay if we don't get to the abstraction, right? It's okay if we don't even necessarily get to the different notation right away, right? Our students might go, I don't really understand it. I see that you're telling me that these are equal. I don't really understand why. That's okay, right? Because it might be, right, that where we said everybody, the light bulb comes on at a different moment. right? So if, here's an example. We all nowadays have access to our local sunset, right? So the sun sets at a different time in my house, to Bab's house, to Amanda's house, to Andy's house, to Nicole's house. Everybody has a different sunset. So if we all have a light that turns on at sunset, right, it's going to come on at a different time for each one of us. And it's the same with understanding, right? The pieces are going to slot together at a different time. And I think we've talked about the analogy of a puzzle. The goal is to get the whole puzzle together, right? There's not, right? If we were in a puzzle competition, right, the goal would be to get the puzzle together, not how we get the puzzle together, not the order that we work in, right? And so everybody is, right, if there's 1,000 pieces, there's like, 1,000 factorial ways that we can put 1,000 factorial ways that we can put that puzzle together. So our puzzle is going to go together in a different order for each one of us, but eventually we're going to see the whole picture.
Okay.
And so for our kids, right, we want to have that same approach that, right, they might see this pattern. On day one that you talk about this, they might see the multiplication pattern and they cannot see the division pattern. So you might come back a few days later and say, okay, let's look at that again. Let's look at it again, right? And they might see it before you see it, right? And so that's when we talk about this pattern finding, though, once we learn to be uncomfortable with the not knowing, right? That's part of our problem here with that we've been sort of ruined by didactic math teaching, because we're never asked to wrestle with something and to live in the unknowing, because we just want you to tell me why. Right? I mean, that's what we're all asking for. It's tell me why. I don't want to do the wrestling. I don't want to live in the uncertainty. I want to know why. So first we have to live in the discomfort of not knowing why, and we have to get comfortable there. And then we have to get comfortable with what are different ways I can look at the pattern, right? And that wrestling, it might take us a while, but imagine that if you graduate a student who is comfortable not knowing something right away, knows how to go and analyze patterns, make their own patterns, and look at the patterns and find truth, and then abstract from that pattern, right? How this all works, they're prepared to do anything, not just solve math problems, right? And so something like this, we're really tempted to jump in, and I'm tempted, right? Because I love what I'm doing. So I love explaining things. I love to sit here and be like, this is why it's so cool. But I really want you all to be encouraged. It's that's really not in our students' best interests, right? That wrestling with this over the course of days, months, years is actually going to build a stronger student, right? A stronger human than just jumping in with, here's the answer and this is why. So just like, when I get hungry and I'm like, I don't want to cut up an apple. I don't want to find a piece of fruit. I don't want to do that. I'm just going to open up a bag of chips, right? It's the same, right? It's junk food. And I'm not saying didactic teaching is junk teaching, but sometimes, right, if we rush to the didactic instead of the wrestling, sometimes it's junk understanding because we haven't really created our own knowledge.
And I think that's the challenge of like when I sit and I go through one problem, it takes me 20 minutes to go through this one problem, and my kid is so exasperated. And I say to them, hey, this is the work. Like, you don't have to do 20 problems, you have to do 20 minutes, right? Like, this is the wrestling is the work. Calm down. Like, because it helps them to release this, like, I just want to get done. There is no done.
Yes.
right? There is no done, there is just understanding.
Yep. I mean, this is a
That's very
perfect
helpful.
thing. If you have like a family whiteboard, put this pattern up on your whiteboard, right? The powers of 10, and just be like, okay, we're going to sit here and we're going to look at this every day as a family until we figure out what the pattern is here. What does this mean? Right? Like pick something. Like we can't wrestle with everything, but you can pick one thing that you're like, this is our thing we're going to wrestle with this week, and let's just keep looking at it, and let's just keep picking at it. Let's keep making a hypothesis and see if it holds.
One
Now
thing
I'm
I
gonna
will
have
say,
like posters put up and I'm gonna be like, we're gonna have math matters sessions. And it's just gonna be like, math matters, let's talk about something. And it doesn't have to have a problem associated with it. It's just a conversation. I love that idea. I'm totally doing that.
I love that idea, Nicole. One thing I was going to say, when my daughter was getting into her own head about switching the denominator to the numerator, I was like, oh, look, I went down to my child in fraction. I was like, look, the numbers are the same, because she was like, oh my word, if it's this hard for monomials, what is it going to be like for polynomials? And so I was like, look, it's literally the same thing. They just added an X. And she's like, oh. And so we looked on the companion for the week for polynomials, and I was like, look, they just added something different. And she's like, oh, okay, I can do this then.
Yay. Well, thanks everybody. This was a long conversation, but I think some really good conversations here at the end. So thank you for everybody who's like hung out and finished strong with us. And I hope it was worth your time, and bring more good questions next week.
Thank you so much.
Thank you.
Thank you for being patient and answering all of our questions.
I love to answer questions.